E noi infatti lo aspettiamo un attimo.
Magari la mettiamo in coda.
Sì, perché
Chi inizia con la prima?
allora inizio io con quella là in PowerPoint e poi dopo inizierà.
Questa?
No?
Questa è di prima.
Questa. Tutto schermo. Non si vede ancora
Non si vede ancora nulla.
No.
No, infatti. Scusate un secondo.
Adesso sì. Sì. Okay, so we can start this session. Good afternoon to all of you. I am Floriana Zuccaro. I am an assistant professor at the Department of Civil Building and Environmental Engineering at the University of Naples Federico II in Italy. And today I will be the chair of this session with the Professor Sabrina Lai, who will coordinate the second time slot after the coffee break. The title of this session is focused on ecosystem services and its role in spatial planning, especially for improving the climate neutrality of urban and rural areas. And this year, this session is within a wider research project financed through the National Recovery and Resilience Plan of Italy, It was one of the main tools of the next generation Europe. The title of this research project is a definition of a guidelines handbook to implement climate neutrality by improving ecosystem service effectiveness in rural and urban areas. A long title, but to be sure that the main goal and the territorial levels involved were all clear. And this is a national research project that has started at the end of the previous year and involved three Italian universities. Università degli Studi di Cagliari, that is the leader partner, the leader university of the project, with Professor Corrado Zoppi, who is joining the session and is the principal investigator. Our university, hi Professor, our Federico II University with the research team of Temalab, and then we will present our research team, and Università degli Studi della Basilicata with Professors Francesco Scorza and Beniamino Morgante. Just to have a general look, to take a look to the whole cluster of papers that were submitted to this session, I prepared a word cloud by using the title and the abstracts of the papers submitted to this session. So we can see that the common traits are energy and climate change, and just these first results give us an idea of the role that for us who are urban planners, the ecosystem services have within the current energy and climate issues that cities have to face. This issue within the papers that we will discuss during this session work at different territorial level. We will discuss about papers related to the urban scale, to the territorial one, and most of them are also interesting because they assess ecosystem services and try to support local policymakers to how better integrate ecosystem services within urban planning and also urban assessment sustainability planning tools. So it is another interesting point. And all the papers have more or less a quantitative approach by using systemic review approaches or spatial analysis and so on. Okay, I don't want to take other time, so we can start. We change the order of the presentations as they are available on the program on the web, and because some other presenters are involved in other parallel session. So the second work became the one. The title is Beyond City Average, Spatial Analysis to Support Energy Saving Interventions in Urban Planning. The authors are Gerardo Carpentieri, Carmela Gargiulo, Carmen Guida, who is the presenter, the speaker, and me. So the floor is yours. Thank you. Just the last information. We have more or less 15 minutes. Also a couple of minutes more because the last presenter of the session will not join it.
Thanks, Floriana, for introducing me to this session. I'm Carmen Guida, a research fellow from the University of Naples, Federico II. I present you today this work titled Beyond the City Average, Spatial Analysis to Support Energy Saving Intervention in Urban Planning. I am researcher at the Tema Lab. Tema Lab stands for Land Use, Mobility and Environment. Some of you had already have a view of our research this morning. It's a laboratory based in the Department of Civil, Building and Environmental Engineering at the University of Naples, Federico II. Our research activity is mainly focused on urban planning challenges, such as climate change, population aging, optimization of land use, and climate neutrality, and with the aim of creating special tools to support policy makers in decision processes. Okay. As a laboratory led by Professoressa Gargiulo, we are involved in a scientific project that actually involves many universities around Italy. This one is NEST, NEST, which stands for Network for Sustainable Transition.
Sorry, excuse me, but would it be possible to see the video of the computer, because or the only way to see the presentation is to look at the camera image which is projected by.
Ah, ok. Forse mi devo spostare io.
Così?
No,
No, forse non lo
no,
vedo.
forse non è condiviso.
No.
No. Now can you see the presentation?
Thank you very much.
Okay.
All right.
Now, check now, because probably the full screen.
No, they see the presentation.
So Tema Lab is involved in a segment of this research led by different Italian universities named NEST, Network for Energy Sustainable Transition. Is a project funded by the Italian Recovery and Resilience Plan. Whose main objective is to create the segment in which we are involved. The main objective is to create an AI-based decision support system to identify key urban areas that require intervention to reduce energy consumption at the urban scale. A few numbers for introducing the topic, the energy consumption topic at the urban scale. Since cities are the biggest consumer or supplied energy, along with urbanization, so the increasing share of people living in urban environment, also the energy pattern follow the same trend. Actually, since the first years of the beginning of this century till the 2030, it's expected for the energy demand in city to increase by 57% in cities. This is mainly due not only to the amount of people living in cities and having a high demand of energy, but it's also due to the concentration of activities and infrastructure that needs to be run in urban environments. These data, if converted in carbon emission due to the high dependency on fuel energy consumption, actually gives an idea of how much carbon emissions we produce, which is about 80% of equivalent carbon emissions. That gives an idea of the footprint of cities for the topic. At the same time, cities are key elements, can be key actors to transform this trend. Moreover, under condition of resource scarcity, which is one of the topics that is being raised recently due to the lack of fossil fuel and the non-renewable fossil fuels, and also climate change, which is now being exaggerated by the amount of emissions and the climate lag phenomenon, cities will need to lower their energy demand and consumption. And due to recent occurrence or even more extreme climatic events, urban planning plays now a key role to support cities to achieve this key actor role within the energy transition that we are aiming to. Of course, much of the literature has been devoted, scientific literature has been devoted to creating a model that can predict energy demand for cities. These are many models have been developed. Most of them actually focused only on a few urban elements, such as building efficiency, transport, mobility. So they usually have a limited understanding of the interconnectedness and the complexity, the dynamic complexity of the urban environment. Our idea is to develop a model which does not predict energy consumption, but is able to classify urban area according to their urban features within a holistic approach that takes into account different elements of the urban environment in order to have a wider look to the city as a whole. Looking at these two images, we can have an idea of what does this can mean. These are two pictures from two different cities, Denver in Colorado and Barcelona in Spain. In the first picture, there are wide streets mainly devoted to car transit. There are missing pavements for pedestrian walking. The single function urban environment, only residential, single family houses that can have an idea, can give an idea, can suggest a car-dependent lifestyle in this urban settlement, versus this idea, which is from the city of Barcelona, where there are walkable streets, again, greenery element, green environment, and a functional mix. Only looking at these images, it's clear that the energy demand of these two environments can be completely different. Hence, the same urban features, green areas, or also the type of construction, the street layout, land use pattern, can have different effect on energy demand in two different urban settlements. That's why, given the idea of the NEST project to create an AI-based decision support system, our research is focused on creating a GIS-based methodology that is able to classify urban areas according to their urban features and the impact on energy consumption within that urban settlement. That's why we are developing a methodology which is made of three main phases, three main steps. The first one concerns data collection and preparation. The first phase actually is dataset design based on literature and data collection taking into account only open source dataset. The second phase is statistical, spatial statistical analysis that is made of two phases. The first one concerns autocorrelation analysis, while the second is made of iterative spatial analysis in order not to improve the final result of the model, because our idea is not to create a perfect model to predict energy demand, but to improve the knowledge of how urban features affect energy consumption. And the third element is the clustering analysis, which will give the idea of urban areas energy clusters. For now, our research is focused on the first two phases because this project is actually ongoing. It will end by the end of 2026. So we are not focusing on the first two phases. And in order to delve into, to have a deep dive of our knowledge according to which urban features affect the most energy consumption, we're focusing especially on spatial statistical analysis and to give the results in forms of maps and charts in order to at least descriptively have an idea of what's affecting energy consumption. Moreover, since this methodology needs to be designed in an open source environment, because the idea of the Italian project as a whole is to give policymakers open source softwares, we're developing this methodology in order to be based only on open source softwares. So QGIS is being used, as well as GWR4, which is a software developed by the geography department of a Japanese university. So the first phase concerns data collection and preparation. Based on literature and also on the availability of open source dataset, a set of 20 variables was identified. Here, y is the dependent variable, which is the energy consumption, and xy to xn is the array of independent variables concerning physical and socioeconomic conditions, features, due to what is commonly known in literature, that gives, of course, way to both subsystems in terms of energy consumption. The following step is about spatial statistical analysis, which has been designed in order to be hosted in a GIS environment, at least partially. For now, we'll see how to develop the final tool. Maybe it will be integrated in a wool software. Well, the first phase concerns a GIS-based exploratory regression analysis. First of that, it's needed an autocorrelation analysis in order to avoid any autocorrelation among the variables. So Pearson correlation analysis is performed before the geographically weighted regression analysis on a set of variables to build up an explaining model of the energy consumption. GWR is a local spatial statistical technique that is suitable for exploring spatial non-stationarity among the variables. So it's particularly advised for complex problems such as this one about energy consumption and the integration with the others. So these are the main differences between the linear regression and the GWR regression. This is an image from the ESRI that gives some idea of the differences. The first image gives so the linear regression gives as an output an array of beta coefficients, which are constant, so always the same in each part of the space. While GWR gives as an output an area of beta coefficient that varies among the territory. They can vary not only in intensity but also in direction, so they can be both positive and negative. So yeah, the main result of this phase is an array of beta coefficients varying for each cell unit, as well as for each variable considered within the model itself. In order to visualize this result, some of the researchers, especially Menis et al., a few years ago, suggested a way to represent visually this result through choropleth maps, which are bivariate maps that, using colors, a different tone of colors, are useful to not only represent the intensity of a certain relationship, but also their direction, if positive or negative. And these maps were recreated in this case because the main idea was to explore to which extent each urban feature was affecting energy consumption. In order to test the methodology, we applied it to the city of Naples, which is the third largest city in Italy. The city has a very complex urban settlement. It is a stratified city, and most of the city is an unplanned urban layout. So also thinking about energy and the main sources of energy for the city, it's quite a complex issue as well. So we decided to apply the methodology for the city of Naples. Also because it's a city we know well, because it's the base, the university where our university is located. This is a map that represents for each territorial unit, which is the census tract from the Italian Statistical Institute, the annual electrical energy consumption per inhabitant. Only domestic use has been given by the Agenzia delle Entrate, which is the Italian revenue agency. And this map is an elaboration, of course, of their data. And looking at this image is, it's clear that there are many different patterns within the city. There are a greater area with the highest energy consumption, while the smallest area are some of the smallest cell unit are those with the lowest, but it's not always the case, since there are many units, especially in the city center, where the inhabitant density is extremely high, so also consumption per inhabitant can be high due to also other elements such as the physical environment, again, the urban settlements that we wanted to investigate with the methodology. All the dataset was created in order to have only open source dataset. So the Italian Statistical Institute was one of the first dataset, and also Corinne Lenkover from Copernicus. And this is the dataset in its form. It's about 19 variables that goes from the social system to the physical system. As I said, they are recognized that the two main systems, urban system, affecting urban consumption. So the first, actually, the first concern the social demographic dynamics. So the age of the population, their education level, or also their employment condition. While in the last group, there are some other variables concerning the density of a building, the kind of building that are relevant for the Naples environment, so masonry and concrete. And finally, the density of green areas, so given as the ratio between green surfaces and census-tract territorial surfaces. So this is the output of the first phase of the statistical analysis concerning the autocorrelation that actually excluded some of the analysis because they recorded a Pearson coefficient higher than 0.7. So these were excluded. It was something that we expected because actually there were some recurring data that were used to compose the index. And the second phase concerned the creation of the first GWR model through the GWR4 software. And you can see here the percentage of cellular units where significant threshold higher than 90% was recorded. This was used not to have an idea of the quality and robustness of the model itself, but we use this data as suggested by some scholars in order to have a deeper understanding of which urban features is actually affecting energy consumption and what intensity. So in the second, we had an iterative GWR, a second model, which actually helped us to exclude other variables. The model, which is the output of this second round, of course, is stronger than the first, is more robust, but this was not the main idea, actually. We excluded these variables not to have the best model to predict energy consumption, because it was not our idea, but we delved into the meaning of this correlation in order to improve the quality of our understanding and our knowledge. In particular, for this presentation and also for the paper we submitted to this session, we focused on the density of green urban areas and its relationship with the energy consumption. And we did through choropleth maps. These are powerful tools recognized by scholars delving into GWR models that can be used to to gain deeper insight into the meaning within the variables themselves. For this map, we chose the red spectrum that represents the significance level of the relationship. So the order of red means how much the significant level is high. Of course, the threshold is 90%. While the blue spectrum represents the direction and strength of the relationship, so if positive or negative. Moreover, we excluded here, it's in light gray, because, well, there is like a net here, but it's not quite visible, where the significance level was lower than 90%. These were particularly significant for the green areas, because of course they're not distributed equally within the urban environment. And also with the dark gray, areas where energy data are missing. This is a chart that is, a synthesis of the data, of the results, because for each Napolitan neighborhood, there's the percentage in red of units where the beta coefficient is positive, suggesting that where the green areas are larger, energy consumption are larger as well. And in blue, units where beta is negative, so where inversion proportion relation exists, while the black dot represents the percentage of green areas for each neighborhood. And these are some of the consideration out of both the map and the histogram itself. Out of 55% of census tract with statistical significant relationship among urban area, green urban areas, and energy consumption exhibited a negative association, suggesting that higher coverage of green spaces tend to have lower residential energy consumption. On the contrary, the 45% of census tract show significant positive relationship. So on the contrary, the urban green areas are and electric energy usage. Also, from the map and the location of this data, some other consideration can be done, because the neighborhoods where the green surface is higher, actually we're talking about San Carlo all'Arena, Chiaiano, and Stella, these three neighborhoods. These are neighborhoods where the density of urban areas is higher, but in this neighborhood is also higher the percentage of units where beta coefficient is positive, meaning that the green areas in this area is not contributing to energy reduction. This is mainly due to their positioning. These are three neighborhoods which had an unplanned, actually, urban planning. Also, Floriana in her presentation will dive into this element, because we found many common features, while other neighborhoods, especially Arenella, Pianura, Posilli, Pompagnoli, Fuorigrotte, and Chiaia. So I'm talking about this area and some area here, so close to the city center, where urban planning was much more controlled. So the construction here was mainly controlled, and these are neighborhoods characterized by functional also mixité, actually are showing, even if higher, not at zero energy green urban areas, they are still showing a high percentage of units where beta coefficient is negative, suggesting that these urban areas are actually contributing to reduce energy consumption. Finally, although this result offers only a preliminary and descriptive view of the analysis of the GWR, they still pave the way for a deeper understanding of the complex dynamics between energy consumption and the urban features. And then we led through hierarchical cluster analysis of the beta coefficient to a classification of urban areas, in order to suggest to policymakers how to intervene properly in cities to reduce energy consumption. So, in conclusion, this exploratory statistical analysis gave an idea of the 6 variables affecting energy, significantly affecting energy consumption. So they gave a knowledge frame that was, a starting point for our research. While analyzing the distribution of beta coefficient among the case study may help to highlight where physical and socioeconomic features are more related to energy consumption. The focus also on green coverage in urban areas suggests significant variation in the strength, but also in the intensity and in the direction of these of ecosystem services within the urban area, also suggesting that is the whole urban environment that affecting the energy consumption. And finally, the proposed methodology will be also revised. There are some limits, of course, related to the fact that for now we are only considering electrical energy use, so we are not considering thermal energy use. So most of these results may be affected also by these limit. So for further research, we are now working both on Naples and in Padova as well, because they're also partner of the project we are in. We'll take into account also these other energy sources, so thermal energy, not only electrical energy, because given also the Italian climate, maybe thermal energy is the one affecting it the most, especially heating demand more than cooling demand. So yeah, still work to do, and we'll keep you updated in case you are interested.
Thank you.
Let's go.
Thank you for the presentation. Are there any questions for Carmen? Yeah?
Go ahead, please. Yeah, just a curiosity, because of course at the beginning I was so interested on the indicators you showed. And I was wondering, why didn't you consider climatic variables in the sense of looking at, for instance, that's surface temperature or the kind of aspects of these things, but also for the morphological aspect or the physical aspects. I saw that there were some indicators to density, but what about, for instance, also aspects to morphological conditions of the neighborhoods, of course, because in neighborhoods also there's a lot of variety in that sense.
Yeah. Actually, we are both trying to consider both these two elements. For the climate condition, we would like to create such a data set that gives an idea of the climate condition of the whole environment. So we're working on collecting temperature, but also wind direction, wind intensity, and temperature. It's quite hard to find this data, but of course they influence a lot these kind of results, also because maybe the same condition of temperature may be different also according to other geomorphological and climatic conditions. So yeah, and also for the physical environment, it's something we're working on, not on Naples, because we had some data missing, especially for morphological element, but for the Padova dataset, even if the area is it's smaller, the data we have are much more in detail for the morphological aspect related to the height of buildings, their distances, distances from streets. So these are all data that will be useful to improve the methodology. For this first case study, we just wanted to have an idea of the affection of, and also to test the methodology itself, because the GWR and also using the GWR not in, copyrighted software was quite a challenge. So yeah, we wanted just to test this first data set to have a control of them all. But of course, we'll consider them all in future applications.
So maybe you to know that there are some open source tools that can help you also mapping like that kind of zones, for instance.
Yeah.
That would be also another valuable sense.
Yes, especially if comparing the cities coming from different territorial areas.
But
So
also really the same city, actually.
yes, also in the same, of course. Thank you.
Yeah, just on that, there are very good packages on R and Python that you can use to do GWR. So we are speaking about software. And my question was related to the GWR. You showed us some map of the beta coefficient, and that was the average of the beta coefficient.
It was beta coefficient, the beta coefficient.
All of them, the
Yes.
average of all of them. So that's just maybe my advice, I don't know. But what's very interesting when you look at the beta coefficient is to look at them individually, because you can have some very low and some very high.
Yeah.
And what's very interesting is to look at some very specific area, which factor are low and which factor are high. And when you just show us the average, we can't know which
Actually,
variable are very powerful and other.
These are the beta coefficient of the variable of density of green urban areas. So this is not the average, it's the beta coefficient of a particular variable.
A particular one or category of variable?
The one variable, the one belonging to the physical environment according to urban areas, because the idea was to, be part of this workshop and focus on ecosystem services, which was, the focus.
And the target is always the energy consumption.
Sorry?
The target variable is always energy consumption.
Yes, the dependent variable is always the same. Yeah, of course, looking at the beta, it's useful only for single variables and to understand, I mean, the direction. But yeah, these are, I maybe said a few slides before here. Yeah, the main idea was to focus only on this one. So yeah, and we introduced, I mean, we tried to implement these couplet maps, which was named in some papers. They were not from urban planning, they were more from sanitary engineering or hydraulic, but it was, I mean, something to experiment. We wanted to investigate these elements.
Just about the visualization, if you do like a Kriging or something on the beta coefficient, you can have just like a filter with a color that will be different, and then you can just put a census track over that without color inside. And I think this is more easy to communicate on that, especially if you work with politicians and the connectivity. Just remarks. So I really like what you did.
Thank you. Yeah, I will follow maybe this advice. Maybe we'll have a chat later. Thank you.
Yeah, another question?
And probably also as a suggestion, it's also useful to show the global results in general to compare and to understand the role. Another issue, you describe urban, but you take only the residential part of the urban environment. Do you think also to integrate the industrial part or the attention on big buildings like public services, big infrastructure and so on?
For now, our segment is also within the project is mainly focused on residential energy usage. So even considering the urban environment, we're only focusing on residential building as a whole. Yeah, for now at least. Thank you.
I can make another consideration about your question because our research group was involved in a European research project some years ago, always focused on the energy consumption of urban areas. We tried for several months to collect data about industrial activities, public building, hosted several public activities, unfortunately without success. It was only just the first big result for us to obtain the energy consumption data. So we hope that maybe in the future with other research projects, we will be able to collect all these kinds of energy consumption. Thank you, Carmen. Okay. So now we can move to the next presentation. And so for the next 15 minutes, I will be the speaker and not long the coordinator of this session. So okay, so as Carmen anticipated, this work is strictly related to her presentation. The title is Greening and Cooling Urban Areas, the Open Space System Contribution for Energy Saving and Climate Change Adaptation. It's another research output of TEMA work group of the University of Naples. And as I mentioned before, the whole session and this work is part of the national research project involving the Free University that you can see here, and also with the professors who are here. And I would like to give some further information about this national research project, as this work is part of its activities. On the left, you can see the three main goals of the project related to the three main universities that are involved. And the second main goal of the project, in the particular, involves our research team, because we would like to develop a decision support tool for policymakers to reduce energy saving and facilitate the adaptation to climate change by focus on a particular subsystem of the urban areas that are the urban open space systems. So our main target is to develop this decision support system tool to, on one side, identify which parts, which surroundings and which open spaces need priority interventions to adapt better them to climate change and reduce energy consumption, and on the other side, to provide a some spatial planning policy recommendation for policymakers to suggest them how intervening on these physical elements. And the development of the policy recommendation will be a joint product of the National Research Project. So this session gave us the opportunity to share with you the first results of our research activity, because as I told before, the project started at the end of 2023. And so today we will focus our attention on two main results. First of all, the outputs of the literature review. The outputs are the main urban characteristics and urban feature of urban open space system that we need to consider in relation to our target of energy saving and climate change adaptation. And another operational result, that is the classification of the surroundings of urban open spaces in the city of Naples by considering their inner characteristics and the urban context characteristics where these open spaces are located. So we are urban planners, so the open spaces are of particular interest for us, because green spaces, squares, public parking lots, abandoned built spaces are interesting physical elements where we can intervene to increase resilience, to realize nature-based solutions, and so to push the way to adaptation to climate change. And due to the multiple and potential benefits that the presence of greening, or at the same time also the improvement of permeability, can give to increase the sustainability and the resilience of urban areas. And these benefits are also really mentioned and underlined in two specific sustainable development goals, the number 11 that all of us know very well, and also the goal number 13 about climate action, because if we look at the targets of the goal number 13, we can see that the green spaces are really underlined and as the key elements for urban areas to reduce energy consumption, to improve the thermal comfort of people, to also promote sustainable mobility, and so in general to improve the quality of life, that is the final goal of our work. So these are the main steps that we followed to during these the first months of our research activity. So first of all, we made a literature review to develop our main set of variables. We collected the data for a part of these variables. We applied a cluster analysis to that allowed us to classify the surroundings of urban open spaces. So about the literature review, actually we made a systematic review. So we started to use the Science Direct international database, and we used different queries related to these three main topics that are the topics of our interest. We collected the papers published in the period between 2015 to the past year, and the systematic review allowed us to, first of all, collect more or less 90 studies, and among them we, at the end, focused the attention on just 18 studies. First of all, because they use a quantitative approach, and then because they try to use a holistic approach to energy and climate change issue, both to a micro scale, like parts of the street, to the whole urban scale. And on the right, you can see just one of the results of this hard literature review. It's just a part, because it is another hard work that we made, where you can see the countries with the highest percentage of case studies. I know that usually we are used to see this kind of maps with the distribution of affiliation universities. And these kind of maps cover also European and the west part of the world. But from our results, if we focus the attention on the urban areas of experimentation, we can see a kind of gap between the specific part of the world and the remaining one. But the blue color refers only to the highest percentage of case studies. In the following countries within the rankings, we have also the European countries. And we also found that a renewing interest in these kinds of issues started again after the pandemic period. In fact, it is clear that starting from 2022, we have another high number of scholars interested in this topic. This literature review step allowed us to define the set of variables that we need to use for the following action of the research. First of all, we identified 4 main categories that are of interest for the research goals. So we define the open space system category, because these physical elements are the key elements for us, because we want to contribute to reduce energy consumption and to adapt to climate change by intervening, by defining the role, the dimension, the distribution of this open system in a holistic way. We consider also the urban context characteristics, because we know that the urban spaces are located in different parts of the urban settlement with the different urban characteristics that can affect their thermal and energy and permeability performances. We consider the microclimate and geomorphological characteristics, because we know that the slope, the temperature, the perceived temperature by people are strictly related with the thermal stress, and also with the possible impacts of extreme weather events like flooding. And we have also socioeconomic and demographic characteristics, because we know that behaviors and lifestyles are strictly related to energy consumption level and also to the thermal demand and behavior of the city. For each one of these 4 main categories, we identified the main characteristics, so the main components of each category, and then the related variables and indicators. So this is a set of more than 40 variables that collects variables that, according to the literature, are significant from a statistical point of view. The variables that are underlined in orange are the variables that we added to the initial set obtained from the literature review. because these kind of variables are of particular interest for us and are in line with our holistic approach to consider the complex relationships among the all different urban components. Unfortunately, by now I will show you just a part of the results, and so we focus our attention on a limited number of these variables, because these variables, these ones that you can see here and the other ones, are the variables that can be collected by using available data. So open source data that didn't require direct observation, like most of these other variables that we will collect and measure in the next steps of the research, because of course they require a huge amount of time. I underline this variable, the overlapping effect, because I will describe it about its measure when I will describe in the next slide the study area. After defining the variables and collecting the data to measure them, we apply the cluster analysis. We in particular use the kappa-means algorithm that use squared Euclidean distances as minimization tools. So it means that each element of the sample is associated to the cluster with the nearest centroid cluster. And this is the study area. Carmen briefly introduced it in the previous work. It is interesting for population, for surface, but it is also very interesting for its geomorphological condition, because it is a hill city and it is also located on a coastal area. So we know that also within a district, within a same district, moving from a block to another one, we have a relevant difference, for instance, in terms of land surface temperature and thermal stress. But this case study is also interesting if we look at the open space system, because it is indicative of the urban planning process evolution of the city or the lack of such. Because, for instance, if we look at districts like Chiaia and parts also Vomero and parts San Ferdinando, they are more or less the result of a unique planning process. So we have a kind of balance between for the presence of green and built open spaces with similar dimensions of these kind of spaces. If we move to the near central districts like Avocata, Monte Calvario, and San Lorenzo, sorry for Avocata, they are the results of an unplanned planning process. So we have small side open spaces with different dimensions, and they are in contradiction with other open spaces that, for instance, are located in the northern suburbs districts that were planned and that are characterized by the presence of some of the biggest green spaces of the city. And they are also less used from the central open spaces located here. And all these open spaces, green and built, in most districts are really close among them. So we decided to consider this proximity of these open spaces by adding the variable of overlapping effect. I mean, I go to the next slide because I want to be clear and I hope to reach this target. We started to study the green areas more or less 5-10 years ago. And we are interested in the relation, the positive effect of green areas in reducing thermal stress. So in our previous studies, we were able to measure the cooling areas that are the areas covered from the reduction of temperature determined by the presence of vegetation. So we were able to measure the maximum extent of the cooling effect of greening. And we defined this maximum extent and the dimension of cooling areas according to the dimensions of the green space, but also to the characteristics of urban context, like urban density. Because the presence of a compact district or compact buildings can represent, for instance, a barrier to the cooling effect. So we defined different cooling buffer, cooling areas according to the main dimensions of the green spaces, and we decided to consider the parts of the urban fabric where these cooling areas are overlapped. By now, we just measured the dimension of these overlapping areas, but as we will see in the last slides of the presentation, we wanted to focus on the thermal comfort of these overlap areas by making microsimulation with MVMet software. The cluster analysis and so the kappa-means algorithms allowed us to obtain 5 main clusters, and we decided to focus the attention on 3 main clusters. Here there is also the numerical parts of the cluster results. That is a matrix where you can see for each cluster, the average value of each variable, the number of open spaces collecting in each cluster, and here in the last column, the average value of each variable within the whole sample. I tried to focus your attention on the 3 main interesting clusters, even if all the clusters are of interest for us. The first one collects the green and open spaces and their surroundings characterized by the high presence of greenery, a low percentage of vulnerable population, and also old-dimensionary buildings. Look at that. This distribution mainly interests the planned districts that I mentioned before, so like Chiaia, San Ferdinando, and Vomero, and other smaller planned parts in the other districts of the city. So this is the reason why we have a high presence of green spaces, also, for example, within squares. In the second cluster, on the contrary, we have the worst situation of the city because they are built spaces characterized by the absence of greening, and we can see the potential of overlapping effect when we will be able to measure them, to consider, to quantify the parts of the urban settlement that can be positively affected by the cooling effect of green areas. While the cluster number 5, for instance, is interesting because it collects the open space and then their surroundings that are located in the northern and in the eastern part of the city, with concrete buildings, high presence of population, and also percentage of vulnerable people. The presence of vulnerable people is also interesting for us because Italy is the second country at world level for presence of elderly, and it is a interesting aspect for us that are urban planners, but it represents also a hard challenge considering thermal stress. And so by adding the social demographic category at the beginning of our presentation, these elements in these parts of the city represent the first hotspot, because we know that in these parts of the city, we should consider the high presence of vulnerable population. So we can suggest to policymakers that in these small portions of urban fabrics, we have to consider the presence of elderly but also children in defining the measure to adapt to climate change. So this first explanatory analysis allowed us on one side to define the variable set that we will use in the next steps, but on one side it allows us also to better investigate our study area by considering the relationships among urban characteristics of open spaces and their context. And in the next step of the other slide, the other one, of the research project, we will focus the attention on the category of microclimate and geomorphological condition, because we want to use the MBMET software to measure the thermal stress. And as I mentioned before, we want to measure the thermal stress and better measure the cooling effect within this kind of stratified fabrics. Because according to the potential cooling effect of the green areas, we can identify different kind of interventions that could realize to promote climate change adaptation, and so to reduce thermal stress, and so to reduce energy consumption. But moreover, we can identify which parts of the city need the priority of interventions, because we know that policymakers absolutely don't have all the resources to make it at the same time greening intervention. And so we have also to support in this sense policymakers. And then we have some main references if you are interested in our work, in our topic. And in the last slide, our main contacts, personals, but also of our research group. So that's all for me. Thank you. So questions are welcome. Please.
Oh, you go first. I really like what you did about the overlapping and all the work on the indicator, which are very good. So my question will look a bit mean, I will say. But the Camin analysis has way more witnesses comparing to all the work you did. So my advice would be to try more robust clustering analysis.
Yeah.
Because I see three weaknesses in Camins in general that I also saw in your analysis. The first one is Camin always give you an average cluster. And you show us on the map as the most significant one, the less significant one in terms of what you were looking for, but you didn't show us the middle one because Camin always gives us that, and that's very bad. The second thing is obviously the random initialization. If you just run it again, I don't know if I will see the same cluster that you just show us. Random initialization. I mean, if you run a cluster analysis, you can run the same again, and you will not have the same result because of random initialization. And the last one is also the probability of going to one class to another. We don't know what is that. So, but you did also work with the indicator. So I would just advise you to go to maybe self-organizing map or maybe Bayesian clustering.
Okay.
Just I want your point of view on that.
Yeah, we will work on all these aspects in the first step. Actually, we decided to focus our main attention and resources on the literature review step because our first main goal was to have a complex but at the same time complete set of variables. So if we will apply another cluster analysis, not with the kappa means, but maybe using the algorithm that you suggest, first of all, we also will need to make correlation analysis because some variables can refer to the same elements, and so we will be able to push the attention on all elements with highest, medium, and low levels, or low values, because high, medium, or low levels means also different levels of interventions, different priority of interventions, and different suggestions to provide for to policymakers. So I know that this is just an exploratory analysis, and a robust analysis should has also been more interesting. But for us, we try to find the better balance between the literature review and first knowledge of this area. But thanks really for your suggestions.
No, you did the honest part already. So.
Thank you.
Thank you.
Please.
No, so I come from Naples, so I studied there, I lived there for 11 years, so I basically lived in all the areas falling in cluster 2, so
okay.
I know quite well the conditions there. And I was wondering, of course, also thinking about the set of indicators that you selected. Of course, in the city center, there's a clear lack of green areas there, right? At some point, I was wondering to which extent also including urban greenery, so basically using NDVI, for instance, to calculate also the presence, at least, of green elements could be also an added value for you. And then I have more reflections or questions, because of course I think the main problem there is actually operationalizing it, especially working on such a complex context, also in relation to, for instance, UNESCO restrictions. So how do you actually can intervene in such a historical context? And also in relation to the solutions, because of course we have quite extensive palette of solutions for greenery, but then I was wondering to which extent it's possible to implement green rules that would be, for instance, useful in the context of the Corte Español, right?
Thanks for your observations. I start from the last observation, that maybe if I lost something, you can remember me. Actually, we dealt with this kind of problem also in another previous work, because we studied the possible application of nature-based solutions in the open spaces in the central area. Nature-based solutions that are climate change adaptation can be realized also in the small open spaces in the central district. I agree with you that it is difficult to, for instance, suggest the change of materials of the perimetration in Piazza Plebiscito Square or near. But in the near districts, we found a lot also of really small squares where small intervention like filtering perimetration at the sides along the perimeter of the square can increase permeability, because I focus the attention on thermal stress, but actually when we talk about climate change adaptation, we want to consider both urban and island and also permeability, so flooding impacts. So we know that in some open spaces, maybe we can realize interventions to increase permeability, while in other ones that have less restrictions and maybe also with the buildings surrounding them, they can put other greening intervention. This is the reason why we want to consider the overlapping effect, because if in a square I can make a greening intervention and in other one I cannot, because there is tendenza, for instance, limit or not, I can measure the cooling effect of the first space where I can realize greening. And so also this other space where, for instance, can increase the permeability can benefit of the cooling effect. And moreover, the buildings that are hosted in these surrounding areas can benefit of it. So this is a first consideration. And another consideration maybe should be made about policymakers' decision. Because as I mentioned, we know that this is a difficult target to reach. First of all, for economic problems, because we know that public funds are not so available and for a long time. But I think that it's more difficult for the mentality of policymakers, Because if we look at the Italian cities, the number of cities that have a climate adaptation plan are very few compared to the other European countries. And so we continue to spend money to recover from the impacts of climate change instead of adapting them, according to economic prevision of ICCSA. So I think that the big problem is not the realization, it's the change of mentality of policymakers, especially for a city as Naples.
I completely agree on this. Why I think actually working on a very small scale, very small pilot cases, perhaps can showcase possibilities in this sense.
The microsimulation that we will make will focus on a really small scale.
The problem with that element is that, of course, you need not really a higher accuracy in terms of modeling, because in the end you will decide what cells and so on. And I think that would be interesting actually to experiment with some solutions. So that would be interesting to actually use it as a way to assess designing strategies.
We want to start from a zero scenario, the existing one, and trying to compare differing intervention scenarios by also combining ENVIMAT with other open sources, because ENVIMAT has a lot of strengths, but yet it has also some weaknesses for other climate variables that other open sources like Rayman allow to calculate. So we will also try to work on this integration of software.
So the first presentation actually, even perhaps tools like UMAP could be also used. For let's say some mid-scale.
We also calculated the UMAP. We didn't consider it in this set of variables. By now we consider also the land surface temperature, but the UI is another variable that we consider. Thank you. Thank you again.
Just
please.
It's a suggestion maybe. Your opinion may give added value to your research, the integration of our well-made transport planning in terms of services to make this area better available.
It can be interesting and useful, especially if we refer to the need to adapt to climate change by referring to sustainable mobility, but also if we focus the attention on the accessibility of open spaces. And so the sustainable mobility, I was thinking at walkability, walking because it is another research topic for us, but also the integration between the pedestrian paths among open spaces and public transport. So it can be another research path to follow in the next month. So thank you. Okay, so we have the last presentation, I hope. Okay, just 1 minute that Rachele comes here from the other parallel session. In the meantime, I can introduce her. Her work is entitled Exploring Approaches to Define Cultural Ecosystem Services in Planning Support System, and the authors are Francesca Perrone and Rachele Vanessa-Gatto. So this last paper is really focused on the ecosystem services. From the other parallel session, I just want to give this information to people is joining the session virtually. So Rachele is coming, please wait for a couple of minutes. we have sealed surfaces and a bad maintenance of the infrastructure to storage raining water.
No, but also if you create open space like a permeable
Yeah.
cement, which
Yeah,
is
yeah,
then
yeah.
actually
Going underground, and also maybe this water can be reused when happens in other city where the raining water is used for agricultural or to irrigate the other green areas of the city. So finger crossed.
this could be very interesting because in the end you have like natural water storage spaces. So.
Yeah, it is a good point for our city, at least for this point of view. Okay, so Raquel, sorry, the floor is yours.
Good morning to everybody. Today I'm going to present a part of research work conducted with Francesca Perrone at the University of Rome. The topic is exploring different approach to define cultural ecosystem services in planning support system. Cultural ecosystem services plays a crucial role in enhancing human well-being, providing tangible benefits such as speed enrichment, aesthetic enjoyment, and cultural identity. This type of benefits that are so immaterial are present as significant challenge due to their nature, no, and multifaceted dimension. So this study critically examines different perspective and methodology used to identify, assess, and classify cultural ecosystem services. There are three main issues related to the potential benefits of cultural ecosystem services in policy making. The first regard the holistic approach, so the adoption of a holistic approach that recognizes the complex relationship between human activity and the environment could contribute in a good form to the traditional planning system. The other issue regarding the fragmentation obstacle that is relevant in the traditional planning system, and this could limit the identification and the integration of cultural ecosystem services in the policy framework. And the third one is related to the evaluation mechanism. So the weakness of the planning system in the evaluation phase could be better managed with the introduction of cultural ecosystem services framework. But what are cultural ecosystem services? There are three types of definition. There are many definitions of cultural ecosystem services, but the main are provided by Mill Ecosystem Assessment that says the categorize cultural ecosystem services into several dimensions: spirit and relational values, aesthetic values, cultural heritage, emphasize the different ways ecosystem contribute to human well-being. The Common International Classification of Ecosystem Services offers a comprehensive classification system that includes cultural ecosystem services one of its core categories, recognizing cultural services as essential components of the human-environment interaction. And cultural ecosystem service framework highlights the importance of incorporating stakeholders' perspective and local knowledge system in assessing, evaluating cultural services, recognize the diversity and the complexity of human-nature relationships. So this type of conceptual frameworks provide just a general guide to identify cultural ecosystem services without going deep into specific cases. So the methodology is trying to define going deep different approach through a systematic literature review. So we select some article that focused on conceptual analysis of cultural ecosystem services, described method, comparing different approach adopted, and for the analysis and evaluation of cultural ecosystem services. And the criteria for selection of this type of articles was limited to the publication from 2012, from 2012 to 2020, written in English and focused on the evaluation of cultural ecosystem services. And articles without open access or not available through the author's university library system were not considered for question of accessibility. And so the analytical framework, going deep two main aspects. So the linkage of cultural ecosystem services to the concept of heritage field and cultural landscape, and the linkage of cultural ecosystem services to the concept of aesthetic and spiritual values. So are managing two main themes. One is more related to the physical and the planning support system, and the other one is focused on the immaterial dimension of the cultural ecosystem services. So the cultural ecosystem services linked to the heritage and cultural landscape are analyzed in two different aspects. The first regards the supply side assessment, so the approach described and considered in the articles analyzed enhance relevant indicator for the supply side assessment of cultural ecosystem services, trying to measure the potential of an area for cultural practice. And the second is main related to decision-making indicators. So the study, some studies identifies a list of the most highly evaluated cultural ecosystem services in relation to their effectiveness in the decision-making process, such as, for example, recreational tourist potential. And the third aspect is focus on indicators in heritage management and planning. So different phase of the planning cycles, where empirical demonstration of the potential application of cultural ecosystem services rooted set of indicators in heritage management and planning of cultural landscapes. While the cultural ecosystem services linked to aesthetic and spiritual values are just some article focus on this aspect of cultural ecosystem services, where the intangible material values of this type of services is really difficult to manage and to assess in a generical way. So the majority says that using participatory assessment and discourse analysis to capture people's perception and experience are the one way to describe the cultural ecosystem services immaterial values, and integrating at the local level place-based approach, so tools for local information acquisition could be a way to analyze, to go in deep this immaterial aspect. So what are the challenges in cultural ecosystem evaluation? First, the methodological complexities. So the analysis delineates the methodological complexities involved identify cultural ecosystem services within the context of heritage research, emphasizing the significance of indicators that measure the potential of an area and cultural practices. The heterogeneous landscape, of course, so despite effort to standardize measurement methods, the study reveals the different type of landscape in evaluation of cultural ecosystem services, and the holistic strategies, recognizing the complexity, in relation between aesthetic, spiritual, and material values. So policymakers and practitioners can devise holistic strategies for the sustainable management and preservation of cultural landscapes. At the end, we have in the cultural ecosystem service in the planning process assume different aspects in the various phase of the planning process. So in the phase of ex-ante assessment, incorporating a comprehensive understanding of cultural ecosystem services can foster more inclusive, resilient, and sustainable planning practices. And in the scenario building, cultural ecosystem services can demonstrate the value or impact of planning choices on main territorial assets and the sustainable development. So by recognizing the valuing the cultural and benefits derived from ecosystems, policymakers can foster more inclusive, resilient, and sustainable planning practice that prioritize the interconnected well-being of both human society and the environment. The opportunity toward context-based approach lie on adopting a comprehensive approach to cultural ecosystem services to reinforce the structure of sustainable policy, to recognize the complex interrelation between aesthetic, spirit, and material values, and to devising holistic strategies for the sustainable planning and presentation of cultural assets. In conclusion, so the study conducted just trying to put kind of order and try to give a structure to read the different type of studies that focus on the identification of cultural ecosystem services, and there is a consistent part of this study that try to standardize and give a generic perspective on the analysis of cultural ecosystem services, and the other part suggests to integrate the local analysis in relation of the local context that is tailor-made.
Thank you. Thank you, Rachele, for your presentation. Any questions? Rachele? No? No questions. Thank you. So, this first time slot...
Excuse me, Floriana, can I raise a question to the last presentation? Yes. My question is the following. Apart from the question of how to identify different kinds of cultural ecosystem services, which are quite differentiated, dishomogeneous, and so on and so forth. I would like to see if there is also a question of measurement of and how to measure cultural ecosystem services, because I think that if you consider planning processes, and if in a holistic point of view you consider the planning process as embedding the question and the use and the planning of the futures based on the futures of the spatial context to which planning is referred, based also on the future framework of the supply of cultural ecosystem services. I think that there is an important question concerning how to measure, because if you are going to integrate ecosystem services, I think that you should also have at least in qualitative terms, but some way of measuring how much and to what extent you have to consider the question of the supply of cultural ecosystem services.
Yes, for this reason, for example, the main topic of my research regarding the tourism ecosystem. So we're trying to measure and to describe the tourist phenomena regarding heritage, cultural heritage, and in the view of benefits, measure benefits. So of this type of cultural services in the environment, and at the end, for example, we are trying to structure set of indicators that allow to measure the potential of cultural entities in the planning support system and the environment. So this part of the study was just a very superficial,
very initial.
See, so it's not the real. We study different studies that consider indicators just to define cultural ecosystem services. But at the end, there was a kind of conclusion about the measurement of the aesthetic value. How you can say that the Colosseum, for example, is had more value from the ancient.
Thank you.
Thank you, Professor Zoppi, for your question, and to Rachele. Actually, this was the last presentation of this first time session, because the last speaker, according to the program, will not join our session, so we can have the time coffee break before continuing. Just the last information.
Oh, Floriana, but are we going to present our paper, me and my?
There is another presentation, the first time slot. Just a second.
I guess so.
Okay. So sorry if I have the. If I no, from the beginning. Okay, yeah, sorry. I was sure that your presentation was in the second part with Professor Sabrina Lai as coordinator. So we have another presentation. Strategic environmental assessment as a tool to embed climate change adaptation in urban planning in the case of 4 Italian cities. And we have Professor Corrado Zoppi as author, together with Federica Leone, Sabrina Lai, and Federica Isola. So sorry, Professor Zoppi.
No problem.
Time lost.
Okay. So can you see my screen right now?
Not yet. Just a second
Okay.
that we share. Okay, now we can see and you can start.
Okay, thank you very much. So we are going to present our paper about, as Floriana said, a strategic environmental assessment as a tool to embed climate change adaptation in urban planning in the case of 4 Italian cities, 4 Sardinian cities, in 2 parts. The first part will be related to the method, a couple of methodological remarks, and I will report these methodological remarks in a few moments, and then the part of the results which will be presented by my dear colleague Federica Isola. And okay. As regards methodological remarks, I would say that our evaluation, our assessment of the embedding of climate change adaptation into municipal planning processes is based on the well-known references, which are the EU strategy on adaptation to climate change, which was implemented into the Italian programming and I would say ruling framework through the Italian national strategic strategy for climate change adaptation, and the most important results, operational results concerning the implementation of the national strategy on climate change adaptation is the recently approved National Plan for Climate Change Adaptation. And our methodology uses the strategic environmental assessment framework of the municipal master plan to show how the national plan for climate change adaptation can be embedded, can be integrated into the planning processes concerning municipal master plans. Of course, there is no time to go through all the question concerning the definition of the national plan for climate change and adaptation, but I would say that it is clear that it is the operational implementation of the national strategy, since it is based on 18 sector reference areas, which are the very same areas the national strategy for climate change and adaptation is based upon. So the methodology that we have used and we are using to integrate climate change adaptation into municipal master plans through the strategic environmental assessment procedure starts from the first step consists of identifying the objectives among the several objectives concerning the 18 areas of the National Plan for Climate Change Adaptation. The objectives, the specific objectives derived from this 18 areas, which can be considered as important, as relevant for planning processes. So, which are the specific objectives defined by the framework of the national plan, which are important, relevant, in case we have to consider these objectives as part of the framework of a municipal master plan. So this is the first step. We identify, we select the objectives which are important, relevant, which of course this is a subjective way of considering the national plan for climate change adaptation with respect to the municipal master plan, to the municipal master plans. Then there is a second stage where we consider the PUC, means municipal master plan, in Italian piano urbanistico comunale, municipal master plan. So we consider on the one side the goals specifically defined in detail with respect to a particular, a local municipal master plan, and then we consider these objectives, and we relate this objective to the set of objectives which were derived from the national master plan. And then in the third phase, we redefine the locally defined objectives of the second stage in terms by embedding the question of the national plan for climate change adaptation with respect to the objectives that have been selected. In order to select the municipal master plans to which apply this methodology, and in which, with respect to which implementing the objective of the national master plan, of the national plan for climate change adaptation, we consider 4 municipalities which are selected through the among the municipalities of Sardinia, considering the 3 criteria which are listed here. So the municipal master plan should have been approved, so they should be operational in terms of ruling the possible futures of the cities to which they are related. Then these cities should show significant population for the Sardinian context, and then the strategic environmental assessment documents, and of course the planning documents should be completely available on and freely available on the institutional websites of these of the municipalities, and that's why we have selected these 4 municipalities which comply with all the 3 criteria which are listed here. And so this is a very quick sketch of the 3 stage of the 3 step of the methodology. So first of all, we identify among the specific objectives of the national plan for climate change adaptation, those objectives which are related to municipal master, which are likely to be related to municipal master plans. This is the area of hydrological instability. This is one of the objectives that has been selected, improving emergency management by the administrations at all levels and increasing public participation. And then the National Plan for Climate Change Adaptation shows actions, measures, or operational way of dealing with the objective, a description, and then also a set of tentative indicators. The second step related to each objective of the National Plan for Climate Change Adaptation, we identify among the objectives of the municipal master plan, those objectives that are related to this objective of this selected objectives of the national master plan, and then we reframe the definition of this objective, taking account of the objective of the National Plan for Climate Change Adaptation. And in this third sample table, we see how starting with the objective of the National Plan for Climate Change Adaptation, and considering the starting objective of the municipal master plan, we associate to this objective, all the objectives, including the starting objective of the National Plan for Climate Change Adaptation, and then we reframe the objective of the municipal master plan through a wide consideration of all the objectives that, of the National Plan for Climate Change Adaptation, which are related to this objective. And then we define also the municipal master plan planning actions, which should be implemented also in normative terms in the final definition of the municipal master plan. So now my colleague Federica Isola is going to show you the results.
Okay. Thank you, Corrado.
Sure.
Okay. It's possible to see? Okay. Thank you. Good morning to all. The second part of this presentation focuses on the results of the application of the methodology, and the study highlighted that the issues of hydrogeological instability, the transportation system, and urban settlements are key elements in terms of integrating climate change adaptation. We will focus on the theme of urban settlements, and the table show the connection between the objectives of the National Plan of Climate Change Adaptation and the objectives and actions related to each of the logical framework of the municipal master plans. That is how the climate change adaptation theme has been integrated into the national plan. To summarize, there are 4 objectives of the national plan referring to urban settlements, and there are 4 objectives of the national plan's climate change adaptation referring to urban settlements. And let you see how the logical framework of each of the municipal master plans responds in terms of strategies related to the climate change adaptation. And about the first, for example, about the first National Plan Climate Change Adaptation urban settlement goal, improving thermal comfort and quality of life, every logical framework of the 4 municipal master plans presents a set of actions related to the national plan goal. In particular, 2 categories of action could be identified. The first, action for the qualification and recovery of the built features of the urban areas. And the second, actions for the requalification of spaces in the proximity of the urban areas. In the case of the municipality of Salargius, must of action refer to the definition of intervention aimed at the creation of green areas and the improvement of conditions of existing homes. The action in particular refers to the objectives of pursuing an environmental policy aimed at increasing the quantity and quality of green spaces in the urban and suburban context, and encouraging processes of the reconfiguration and regeneration through raising the building quality of public spaces and facility. The second objective, the second, the third, but it is important to see for the last objectives goal, promoting planning and design for risk prevention and facilitating monitoring. Only three municipal master plan integrate the climate change adaptation issue. These are the municipality of Capoterra, Nuoro, and Salargius. The categories of actions can be traced to actions to protect and preserve areas of special landscape importance and action to ensure the safety of the territory. For example, in the case of Salargius, 10 actions related to the objective of National Plan of Climate Change Adaptation, largely aimed at defining precautionary measures in the new residential and productive expansion areas, planning intervention aimed at mitigating and reducing hydrological risk. And so we can summarize the results of this study by pointing out a few issues. The analysis of logical frameworks and environmental report of the municipal master plans show that the issue of the urban settlements is an important issue in policy making that integrates climate change in the ICCSA process. And this implies, in particular, this implies that it is essential to integrate measures to improve the quality of life of local community by increasing their resilience to climate change into processes and urban regeneration and expansions of settlements fabric. And the local dimension is the only appropriate scale of analysis of critical issues due to climate change. And finally, we must define an effective adaptation strategy immediately. It is possible to define some policy implication. Planning policies aimed at integrate climate change adaptation into local planning processes must be based on the logical framework of the environmental report of the ICCSA, the municipal master plans of the 4 cities of Sardinia. These policies must also consider the plan action that must be taken to achieve the specific objectives. The plan action, in particular, which are the operational part of the ICCSA of the municipal master plan, must be classified effectively. This can be done by representing them under the 3 general themes: the establishment of expansion of green area, park, outdoor recreational areas, on the forest, wooded areas, and trees. The appropriate management of the water resource regime on the municipal spatial context, and the greening operation refer to existing buildings of new developments. one effective approach to incorporate a set of rules explicitly linking the climate change adaptation related planning policies with the implementation of land use regulation into the municipal master plan. Statutory code is to establish project worksheet as perspective guidelines integrated within the plan code. Finally, this methodological approach is an important tool of supporting decision-making processes related to spatial planning. It can and should be applied in various European Union member states. In particular, the methodology employed will assist the public administration and local authorities in addressing the impacts of change in land cover and land use. Inclusion of climate change adaptation related measures within the policies of municipal master plans is essential to guide decision making toward the prevention or mitigation of damage caused by climate change impact. Thank you so much.
Thank you, Federica and Professor Zoppi, for your interesting intervention, and I apologize again for the mistake in the order of presentations. Any questions?
No, not a question, just a comment.
Excuse me. Could you be close to the microphone, because if not, it is not possible to listen.
Please.
To hear you.
Not a question, of course, just a comment, because I'm aware of the stream of the research, so I think that we are going we have the opportunity to integrate the proposal you discussed today also with what we are trying to organize for the other PRIN, the geodesign one, because we started similarly from the analysis of the NPCCA list of action and activity in order to select and to classify those actions accordingly with the specific suitability issues in our implementation context. So I think that we will have the opportunity to integrate those two research in order to capitalize or even better the results that we are trying to achieve. Thank you. Just a comment, not a question, of course.
Thank you, Francesco. Yes, I think that if I can comment on the comment, I think that this is a very important question. It's not if we stay at the academic point of view, then we can be happy with what we had. If we would like to transfer a methodological, very simple, not very complicated methodological approach in order to integrate this, as Francesco was saying, to integrate the whole this is very complicated framework of the National Plan for Climate Change Adaptations into the local plans. Then I think that the road that Francesco has depicted could be a good way to go through. So thank you very much.
Okay.
Thank you.
Thank you.
Okay.
Professor Zoppi, could you stop the sharing of your screen?
Yeah.
Okay, so thank you for joining this first part of the session on ecosystem services. I think that before continuing with the second part, maybe we can have 5 minutes for a quick coffee, and then we can continue if especially Professor Sabrina Lai, who will coordinate the second part, agrees with this proposal. Sure, you deserve a break. So let's. Okay, so we meet here in 5 minutes, more or less.
Okay.
See you soon.
See you later.
Okay, see you soon. Thank you. Thank you.
Thank you.
Sabrina, non c'è ancora niente, giusto? Hai il microfono spento.
Eccomi, no, ancora niente, vedo che da noi non ci sono, che mancano le prime due presentazioni, della seconda lo sapevamo, della prima no, però non vedo nessuno da Milano. Quindi a questo punto abbiamo 4 presentazioni, la prima è la nostra.
Va bene.
Sorry to keep you waiting, Stelios and other people who I don't know. So the issue here is that the previous session was quite late, so people in the physical room needed to grab a coffee, and they said it was gonna be 5 minutes, but now it's like 15 minutes. So I think we should start, but apparently there won't be any issues with timing because we're missing for sure one presentation, and I don't see any of the people from the first presentation in the virtual room. So I guess there would be just 4 presentations, so we can keep to the 12, 13 minutes for each presentation, and so that we can have a round of questions and answer. Because there's going to be no presentation from the physical room, then I think we can start, and when they're back in the room, they will join us. So welcome everybody to the second slot of the session, Ecosystem Services in Spatial Planning for Climate Neutral Urban and Rural Areas. This is the 3rd year we're running a session on ecosystem services in ICCSA, and we're very happy for it to be up and running. So because the first 2 presentations are missing, I think the first one will be Corrado and myself, and we will be talking about regulating ecosystem services in the urban area of Cagliari. So I will start sharing my screen. And I think you can see my screen. If not, just let me know. With this study, which was carried out by Corrado and myself, we will be looking at what are the main factors that drive the presence of urban ecosystem services, and we're going to look especially at regulating ecosystem services. I will start by introducing the research questions, and then I will briefly talk about which ecosystem services are we looking at and how we model them, and which are the related factors which we took into account. Then I will hand over to my colleague, who will present the results, the discussions, and will introduce some policy implications, and will conclude the presentation. In urban areas, ecosystem services are important, but at the same time they are constrained by the presence of soiled land. And by soiled land, soiled soils, what we mean is paved areas where there's no vegetation, but also the porosity and permeability of the soil has been reduced through concrete buildings, presence of infrastructure, and whatever you can think of. So our question is, to what extent the endowment of sealed and unsealed areas affects the supply of ecosystem services. And we are especially looking at 3 regulating ecosystem services, of which the first one is carbon capture and storage. And carbon storage is the ability of vegetation and natural soils to sequester carbon from the atmosphere. And then through photosynthesis, it's stored in the vegetation and passed on to the soils. And for this to happen, of course, we need vegetation and natural soils, which means that land cover changes heavily affect the provision of these ecosystem services. So we need to have some kind of urban policies and urban planning in place for vegetation and natural soils to be conserved so that they will keep storing carbon. The second ecosystem service we are going to look at is the runoff control. So as you can see from the picture on the top, when the soil is natural, when there's little or no building, then what happens is the porosity of the soil makes it possible for the water to infiltrate the ground and to be stored into the underground aquifers. But when there's building and land cover changes, then what happens is the soil becomes impervious, so there's less penetration, and also the heavy load of infrastructure and buildings makes it affects the soil in a way to reduce porosity, which means that if we want to retain runoff control, then on a planning side, we need to manage effectively water courses and floodplains. And we can do that in urban environments by using nature-based solutions such as the ones you can see in the picture: retention ponds, bioswales, rain gardens, but also very simply like permeable pavements and sidewalks. And finally, the third ecosystem service we are going to look at is the mitigation of the temperature in the urban environment. And we look at especially the land surface temperature, which is defined as the radiative skin temperature of the land surface, because there's data available worldwide, very accessible on this. And if you look at the picture with the energy budget, what happens is that the sun emits energy that is in part absorbed by land and ocean, and it makes the temperature rise. And this rising temperature is higher when the soils are paved, whereas natural soils, vegetated soils, tend to show lower temperature, everything else being equal. So what we did is we assessed and mapped through various models the three ecosystem services I mentioned, and we used as a case study the city of Cagliari. And as a reference mapping unit, we used the census tracts in the city. Whereas as explanatory variable, then we are looking at the vegetation, so trees, shrubs, but also grassy area. And from the built environmental perspective, then we use the variable which has to do with the density of the buildings, whereas a second soil sealing related variable is the share of sealed area within a census tract. And also a third factor is the density of housing unions. And finally, a demographic factor, which is the population density. And also, and finally, still related to the demographics, the share of residents that hold a higher level degree, so a college degree, which we took as a proxy for income, because we didn't have any data on this aspect. And I will hand now over to my colleague who will explain the results.
Okay, thank you very much. Can you hear me?
Yes.
Okay. I have to. Okay. Can you see my screen right now?
Yeah.
Okay.
Yes.
So, as Sabrina reported a few moments ago, these are the variables that we considered, and so we ran three regression analysis concerning the taking as a dependent variable the three variables which are associated to the supply of the three ecosystem services which were described and discussed by Sabrina, so carbon capture and storage, runoff retention, and mitigation of land surface temperature. And the results are shown in this table. And concerning the results, we have these notations. First of all, with respect to carbon capture and storage, we have we see that the share of the spatial context covered by trees, by high vegetation, is negative and weakly significant, which means that the fact that the presence of trees does not help in terms of increasing the carbon capture and storage ecosystem service. This is fundamentally due to the fact that this is expressive picture of what happens in terms of trees planted in the context of the municipal territory of Cagliari. There is a very small area which can absorb and store carbon dioxide, and so the presence of this kind of vegetation does not help too much in terms of carbon capture and storage. Moreover, in a recent study by Havu and others, street trees could be another complementary reason for these poor results in terms of tree coverage in terms of capture and storage of carbon dioxide. The trees can work as emitters and also as sinkers, depending on their age. So since we don't have systematic data concerning the age of the trees planted in the Cagliari municipal area, then we can hypothesize that another reason, complementary reasons for this not good results, is related to the fact that the trees in Cagliari are a little bit aged. I hear something in the audio, so I would say that maybe everybody can close his microphone. And whereas the vegetated area by low and medium height vegetation give a positive and significant contribution to the supply of carbon capture and storage, which is a result which is can be confirmed by several studies in the current literature. Then, with respect to the second ecosystem service, the supply of runoff control, we see that, low and medium vegetated areas give act as favorable driving factors with respect to the supply of runoff control, which is fairly intuitive. Permeable soils are, of course, favorable to runoff control, whereas this results highlights also the fact that is confirmed also by the analysis of by the correlation analysis with respect to two variables which are considered as proxy for the fact that the soil are permeable or not permeable, pervious or not pervious. Then, with respect to the third ecosystem service, so heat mitigation, we see that, which is also fairly intuitive, an increase in the size of treat areas gives a positive contribution to the supply of the heat mitigation service, since it is negative related to land surface temperature. But what we observe with respect to the correlation between land surface temperature and heat mitigation, we see also that even though the impact is significant and positive, the magnitude, the size of the impact is small, and this is due to the fact, this is probably due to the fact, this points out that more analysis should be developed with respect to this point, to this question. We see that the effect of tree canopy is positive, but the size of the soil covered by tree canopy also matters. It is important since the more tree canopy areas are fragmented, so the lower the size of the average size of tree canopy covered areas, the lower is the effects in terms of mitigating heating waves and heat and the related phenomenon of heat islands. So the tree canopy is important, but it is not decisive. You have to consider also the fact that you need very large areas in order to boost this the effect of this factor. And whereas the effect of perk bush, the soil covered by low and medium height vegetation coverage reveals a negative impact on the, so it is not positively related to the heat mitigation phenomenon. So what is important is tree canopy, but tree canopy should be also based on areas as large as possible. So the policy implications are quite straightforward. Since in terms of runoff control, in terms of in comprehensive terms with respect to runoff control, carbon capture and storage, and mitigation of urban heat phenomena, the increased size of vegetated areas and the increased size of tree canopy should be implemented in order to increase the supply of the three considered ecosystem of the supply of the three considered ecosystem services. And so in comprehensive terms, the quality of life depends on an increase of the urban greenery, even though with different importance and relevance with respect to the three ecosystem services, to the three considered ecosystem services. In terms of operational planning policies, there is, of course, a question, an issue related to the rules that should be made operational in terms of building permits, which should preserve the existing green areas in the city, and also the rules, the planning rules, the planning regulations should aim at possibly increasing the size and the number of the green areas, with particular reference to tree canopy and also to medium height plants. Of course, the rules cannot be enough to implement this kind of policies. You need public financial incentives, and so you should invest in urban green areas, accessible, usable, and with a significant size of each of them. And then there is an important question related to the public awareness, the public perception of the importance of the fact that that the local community perceive that the local governments act in terms of increasing the supply of carbon capture and storage, runoff control, and heat mitigation in terms of operational policies. And so flagship financial operations, not only financial, but also physical operation should be very important as focus is on this question. Final remarks about the studies that we have presented. There is the value added of the methodology can be identified by the fact that it is based on data which are usually freely available, almost freely available for all the European Union, but also the I would say, the world most important most important metropolitan cities and urban areas. So it is easily exportable, what we have done here. This also it is shows a significant relevance in terms of the possibility of comparing results concerning different urban and metropolitan areas belonging to different national and international contexts. And finally, as we have also tried to put in evidence in this quick presentation, there is plenty of room for future development in terms of fine-tuning of the way the different the supplies of the different ecosystem services are calculated and are estimated, and also there is plenty of room for increasing the set of the ecosystem services that can be considered at the urban and metropolitan level in order to evaluate the factors that are related to the supply. Thank you very much.
Thank you, Corrado. And there were questions online with the schedule of a session. Let me repeat that we're missing the second one, and the first one asked to be postponed. So we started with the third one by Corrado and myself. And then the first presenter has joined us, so we will have them, and next we will follow the schedule. So Bilge Kobat afterwards, then Stelios and Dimitris, and then Federica, and Rosanna. Any questions for Corrado and myself from the audience? Okay, apparently not. So we'll see if there's time for a round discussion at the end. And I would ask you now, Silvia, to present Silvia Ronchi, Exploring Urban Metabolism Through Ecosystem Services Mapping, the case study of Turin, Italy. And Silvia, you have 13 minutes, and I will give you a warning when you get to 10. That's okay?
Yes, thank you.
Thank you so much,
everyone. I'm sorry for the delay.
Don't worry, it's okay.
Okay. Okay, now you can see the full screen of my presentation.
Yeah.
Okay.
Yes.
Okay, perfect. So good morning to everyone. I'm Silvia Ronchi from the Department of Architecture and Urban Studies of Politecnico di Milano. I would like to present you this first preliminary research called Exploring Urban Metabolism, and we would like to investigate this topic using the ecosystem service framework and with a case study of the city of Turin in the northeast part of Italy. So we would like to start with some first assumption, quite well known. So the cities are responsible for over the 70% of the global emissions. So it's quite urgent for us to try to adopt a low carbon and resilient urban development strategies to mitigate and control the climate, the global warming, and also the climate emission. And these challenges is addressed in several EU policies. Among that, there is the EU emission climate neutral and smart cities that aim for 100 climate neutral cities by 2030, inside the more general European Green Deal targets that climb for climate neutrality by 2050. For reaching this quite ambitious goal, cities are considered as a sort of dynamic system that both contribute to mitigate and adapt to climate change. So from the perspective of urban planning, is fundamental for improve the performance of the ecosystem in providing services and some key tools that can do this kind of job, so trying to mitigate the effect of global warming, are the NBS, so the nature-based solution, and the green and blue infrastructure that can provide a multiple function of ecosystem services. These actions need to be considered, so we would like to consider this different action in an urban metabolism perspective. So analyzing the energy and the material flow within cities, try to guide the cities towards strategy for energy efficiency, waste reduction, and also resource conservation, especially natural resource conservation. This approach can be applied for achieving the so-called climate neutrality, also promoted by European Commission, and advocates for action that not only mitigate climate change by reducing emission, but also try to improve the quality of cities and enhance their capability for be more resilient and more adaptable to climate challenges and extreme events. So cities are very relevant in this perspective, and urban planning can improve the quality of the cities for reaching the ambitious goal of climate neutrality. So why we decide to try to explore this method and these topics? Because we have the goal that also European Commission promote, and we would like to reduce our emission. But to do that, we think that it also is essential to understand how many emissions are released from the different cities into the atmosphere, and what is the contribution of ecosystem in trying to reduce this kind of concentration. So knowing what is called the urban metabolism of a city, and then we can adopt the most effective methods for specific situations. So a sort of tailor-made strategies. The city all function in a very different way, so it's important for us to start knowing this kind of metabolism. So what are the emissions, so the quantitative of emission, what are the sources of this emission, and what could be the strategies for improve the ecosystem, trying to mitigate this kind of effect. So urban planning in this framework is totally is the core of our strategies, trying to make all of this strategy operative and practical. So our aims in this research was to test and practically apply the methodology and also validate the framework of our methodology. The activity is carried out within the Climaboru project. That is one of the 3 projects that work on urban planning and design in the framework of the 100th Climate Neutrality Smart Cities mission. You can find the website with all the information related to Climaboru. And within our aims, we would like to map and assess the key relevant ecosystem services for the city of Turin, and trying to see what could be the strategies that from this mapping analysis we can provide to policymakers for identifying the most suitable strategies for urban planning purposes towards climate neutrality. We use the case study of the city of Turin, also because it's one of the different cities involved in Climaboru project. And we are in the northwest of Italy, in Piemonte region, and we are located along the Po Valley, that is characterized by a flat area where all the urbanized area of Turin is concentrated. This is a picture more zoom in to understand the different configuration of the cities. Is a city of 900,000 of inhabitants for a territorial extension of more than 130 square kilometers, and is characterized by this very flat area, totally, quite urbanized. And in the surrounding areas there are different hills with different altitudes that reach up of 715 meters. Turin is characterized by to be a compact urban basin with a densely built up core and with a low permeability in the sides, so in the flat plain. The city has a lot of different a series of natural parks. In the picture, you can see the different also stream that involves the city of Turin, the Stura stream, the Po River, Sagona streams. Along these different rivers, there are a concentration of different parks characterized from being more natural and also more related to recreational function. We decide to include Turin as a case studies because there are different environmental challenges inside the cities. So the city faces significant environmental issues such as combating air pollution, managing the urban expansion that are even if close to the natural area, and try to mitigate the urban heat island effect that is very important, very significant in the urbanized area, in the plain area. So considering all of these challenges, the city has demonstrated strong commitment to environmental sustainability. So in 2020, the city adopted the climate resilient plan, and in the year after, so in 2021, the strategic plan for green infrastructure. So there is a different initiative in the cities, and they also need to integrate all of these contents in urban planning. So not considered as a separated tools, but try to combine this knowledge in the traditional urban planning process. We start developing the first step of our research methodology, that is the ecosystem service mapping and assessment. So we start considering the carbon storage. We develop more or less all this mapping using Invest software. The first one is the carbon storage, and from these maps, we can see that Turin has a significant capacity for carbon storage, averaging 47 tons for hectares. And obviously, the natural yield in this area, if you can see my mouse, are particularly effective, storing up to 218 tons per hectare. So urban metabolism approach showed that Turin's urban ecosystem try to capture enough carbon to offset about half of the city's greenhouse gas emissions. So the demand for air and water purification exceed what the urban ecosystem can currently provide. So this is quite significant also for setting some strategies from urban planning strategy that could be very efficacy from this point of view. So the need for a better urban planning and the increase of green spaces is necessary to improve the city sustainability by using the carbon storage ability of urban and natural areas. Turin can reach more easily the ambitious target to be climate neutral until 2030 and after 2050. Another mapping and assessment is the habitat quality, also in this case, was developed.
Sorry, 3 minutes left.
Okay, using Invest, and we can see different habitats well preserved, well conserved along the streams and close to the hills. Another maps regard the heat mitigation. That was one of the main important problems that the cities want to cope with, and is to try to mitigate the increase of the temperature, especially during the summertime, trying to mitigate using natural components for reduce this phenomenon. And what emerged is the high contribution of the hills, but also we can see that the hills have the major value, but also is an anthropized hills, because over the years there is a strong pressure for create new area, especially residential or facilities area, that decrease the natural quality of the area and also the capacity to mitigate the urban heat island effect. Another mapping concern the water regulation, so try to see what are the retention index of the cities, so the soil capacity to hold water during a year. And what emerges is that 45% of the rainfall infiltrates soil, while the 46% runoff So it's quite relevant, and we can identify precisely the area that need to be desealed to increase the infiltration of rainwater into soil to avoid the risk of flooding, urban flooding. The last assessment regard the air purification. In this case, we use the model of I3. I need to say that we don't have information for the hills because we use the urban tree catastrophe of the city of Turin. So we just have the information for the urban area, so the trees that are managed by the administration. And for in this case, we can see that it's possible to estimate that the total amount of trees in the city of Turin removes 55 tons per year of the different pollutants like CO3, carbon monoxide, particulate matter, 2.5 and 10. So the spatial distribution maps correlate the tree density with the pollution mitigation. So highlighting what are the benefits from the area, from the urban greenery. And this map is very relevant also to understand what could be the possible strategies to increase urban forestry in the city of Turin, or what are the area well designed from the urban planning perspective that need to be maintained and preserved because they provide a very important services in terms of air quality and air purification. I just arrived at the end with some elements that can support a new urban planning, a sort of performance-based urban planning, considering what emerged from the ecosystem service mapping. And these are 5 key points. The first one is that emerge very clear the habitat degradation along in the urban areas, but also in such natural areas like the hills that need to be limited and mitigate as soon as possible in order to inverse the degradation of this kind of habitat that are very, very relevant for provide important ecosystem services. And the other aspect regard the flooding risk. So we identify precisely the area that are involved from this phenomenon. So we can use NBS that can, in an operational way, try to mitigate this problem. Another issue regards the stormwater challenges that affect different cities in the world, and we can implement a very specific NBS that can improve the infiltration of water in soil and recharge the water table. Another aspect regard the renaturalization of such areas like Po, Dora, Stura, and all the streams that involves the city of Turin, try to increase and enhance the biodiversity corridors and also the pedestrian mobility for recreational perspective. In the urban areas where we have different limits for the implementation of NBS, we can use the concept of the sponge cities and try to increase the permeability using porous materials, but also natural area that can resolve the problem of rainfall in soil, so increase the permeability of soils. And the last one is related to the air filtration and air purification, that is the increase in forest area to improve the canopy cover of the city of Turin, to improve the pollution removal made by trees, and tried also to increase the quality of the air. These are first preliminary results that we think that can support the policymaker for try to have a better urban planning process for the city of Turin that need to increase some of these elements in the process of reaching climate neutrality until 2030, as our policies, European policies required. Okay.
Thank you so much, Silvia. I would suggest having a round of questions and answers at the end. Otherwise, we'll risk giving to short time to the next presenters. So I give the screen now to Bilge Kobak, who has a presentation on transformation of disused railways based on eco-service service assessment in the second phase. And Bilge, I will give you a sign when you have 3 minutes left.
Okay, thank you so much. Hello, my name is Bilge Kobak. I'm a PhD candidate in a joint program between USP Pavia and University of Cagliari under the supervision of Professor Sabrina Lai, who also had guidance on this paper. As an introduction, as mentioned in many studies, ES knowledge leads to action since they provide crucial information for decision making. And to improve the relationship between human and environment, ES assessments provide information on areas that are suitable to be designed as ES providers, such as green infrastructure. While green infrastructure can be broadly defined as the collective names of strategically designed green and open space network, numerous ES assessments typically use the spatial distribution of public green spaces as an indicator for ES supply, and they often overlook the ES provided by other types of green areas, such as brownfields and abandoned areas. Hence, there is a need to provide methodologies to assess the suitability of these kinds of areas into GI network. To cover this gap in the literature regarding specific measures to harness their potential effectively, this research focuses on distinctive typologies of brownfields. And since it would be hard to compare a mining land or an energy land to a railway, it proposes a categorization for a more nuanced analysis and strategic planning. And by focusing on railways as part of the transportation category, it provides a prime framework to address and mitigate this gap. Typically, disused or abandoned railways are transformed into greenways, or it's common to make them a part of the slow mobility network. However, their ES values are not much highlighted in the literature, and to highlight their ES value, this paper focuses on cultural ES, since they are associated with intangible values and heritage, which becomes important in this kind of industrial heritage as they reflect the past activities of society. The case study for methodology is chosen as Sassari. It locates in Sardinia region in southern Italy. It's one of the four provinces and characterized by industrial activities. It is chosen because it hosts several abandoned railway lines, including partially operating ones. Analysis of planning documents was also an important part of this study. 5 urban planning documents are identified that are related to Sassari province. I'm not going to go into detail, but I can explain the findings in general. At the provincial level, integrated reports or pacts are signed by various municipalities. However, specific actions are not explicitly mentioned. And notably, documents at the capital city level are more detailed, outlining a few areas of intervention. However, the process is progressing very slowly and still lacks actions. That's why the proposed methodology in this paper is beneficial, since it identifies areas with high recreation potential based on environmental and cultural value. An adapted version of STMAP model is used for the case of Sassari. This model requires 2 modules. One is the natural features, which also includes areas of interest. And the second one is generally referred to as human inputs, and it's in many studies used. Many studies uses roads as parameter here, but a strategic choice is made for this paper by focusing on slow mobility network, since the general aim is to encourage nature-based activities. This includes biking, hiking, and trekking routes, as well as their connectivity. In this map, you can see the total image of abandoned railways in Sassari province from a combination of different sources. The main focus is on 3 railway lines. One is from Sassari to Palau, the other one is Luras to Monti, and then the third one is this part. As I mentioned before, to use the model, 2 modules was required. The recreation potential map of Sassari is drawn by 3 parameters, by the sum of 3 parameters, which is degree of naturalness using land cover, the presence of protected areas, and the presence of areas of interest. And the second module includes the slow mobility network components, as well as their connectivity levels. After obtaining the 2 modules, through the cross-tabulation analysis, areas with significant recreation potential that lack sufficient connectivity could be mapped. This is the final output of the estimate model. It gives us the recreation opportunity spectrum, where we can see the high recreation areas that might lack connections. And by superposing the abandoned railway lines, we can make some connections and recommendations. Starting from Sassari to Palau, there is a biking route following this railway line. Since it connects the capital of the province, it may provide more connections. And there is also a Trenino Verde, which is a touristic route that operates in summer. And this can be improved since it offers people scenery views and landscape quality. And given that this stretch serves as a crucial hub for multiple routes, it's important to suggest interventions that enhances user experience, such as ensuring regular trail maintenance to minimize disruptions, implementing signing signage elements for better navigation, and enhancing security measures while also offering essential services for users. Also, since this stop at Luras is also a part of Tirinina Verde, continues to another stretch, Luras to Monti. So the touristic train stops here before moving on to its final stop. Therefore, it's accessible. This stretch is also accessible by this part. And according to the recreation potential map that is shown before, we were able to analyze areas of interest within 15 minutes distance to this route, and it has a lot of landscape assets, including museums and characteristics of Sardinia Nuraghe. If we expand this distance, more areas of interest would be in the equation. That's why this part is very important also, because of the high number of areas of interest. And moving on to the last part on the south, there is a cycle route available in this stretch between Tirso and Ozieri, which is also a part of the project Ciclovia Sardinia. Hence, it's already recognized as a slow mobility route, although it's very good that they recognize this use railway for recreational activities. There's still room for improvement. And this route, according to different sources, the main source was Ferrovia Abandonate, which gives information about disused railways. This route is invaded by spontaneous vegetation, and also includes works of art along the route, which increases its values. And small houses and former buildings of former stations still exist, which can provide necessary services for users, such as bike maintenance, assistance, food and water. This route is well connected to previously mentioned routes through different hiking and trekking routes. However, to this stretch, it's not connected, and this part is mentioned as deteriorating. So it's in bad conditions, so it's kind of urgent to take action on this area as well. Hence, by connecting this area with other stretches, it would save the heritage. To sum up the recommendations, after providing the connection to larger routes, several shorter routes several shorter routes can be tailored within the area of the stretch for each typology of user, depending on the visitor type. It can be thematic routes connecting to historical sites or sports routes, which has different levels of difficulties depending on the topology of the site. And in this kind of historical context, it is also important for visitors to be able to read the historical layers of the site. Guiding elements and highlighted features to make the history visible to the visitor is very important. And to further enhance the quality of this research, it's essential to ensure that the input data is not only up to date, but also comprehensive. And due to this paper scope, statistics regarding the beneficiaries is not included. However, integrating their demands into the equation along with user analysis would yield more precise results. And further exploration of different types of brownfields and additional ecosystem services would be more effective to showcase their potential. Thank you so much.
Thanks, Bilge. And as I said to Silvia, let's skip questions and answers at the very end in a final round. And let's now move on to Stelios Koutselas and Dimitris Kousios, sorry for mispronouncing your names, with a study titled Description of a Pilot Digital Interactive Tool of Territorial Resource Spatial Projection and Management. Stelios? Stelios, can you hear us? Okay, so if Stelios cannot hear and it's not here right now, let's switch now to the last presentation and we will move back to Stelios afterwards. So Federica Isola, Federica Leone, and Rossana Pittau with Urban Island Phenomenon and Ecosystem Services, a systematic review. Federica, please.
Can you see the presentation?
Yeah, full screen mode right now.
Yeah, okay. So good morning for those who are in Italy, and good afternoon for those who are in Hanoi. I'm Federica Leone, a researcher at the University of Cagliari, and today we'll be presenting a study prepared together with my colleagues Federica Isola and Rossana Pittau. The study reviews the existing literature concerning the mitigation of heat island effect through ecosystem services in order to understand how they are studied and analyzed in the international scenario. According to the United Nations report, in 2018, more than 55% of the world population live in urban areas, and it is expected that by 2050 the percentage will grow. The increasing rate of urbanization and the continuous increase of population in urban areas have entailed several problems which impact negatively on health and the well-being of population and on the environment in general. Urban heat island is defined as an urban area that is significantly warmer than its rural surroundings due to artificial infrastructure and the human activities. One of the main causes of rising temperatures in urban areas and thus the occurrence of urban heat islands is impervious surfaces, which in turn led to poor thermal comfort in cities. Ecosystem services, and in particular regulating ecosystem services such as local climate regulation, are considered as a valuable tool for mitigating the effect of urban heat island. Ecosystem-based adaptation approach to urban spatial planning can be a key element of establishing urban policies focused on natural resources management. Starting from this theoretical framework, the study proposed a systematic analysis of a part of the existing scientific literature on the mitigation of heat island effect through ecosystem services, with the aim to understand how this phenomenon is internationally studied and analyzed. The sample of papers to be analyzed was selected from the Scopus database using the combination word that you see on the slide within the field article, title, abstract, keywords. The preliminary paper selection resulted in the identification of 331 papers spanning a period from 2007 and 2023. The paper selection phase was structured into two evaluation steps. In the first step, all abstracts were analyzed in order to exclude papers not related to spatial and urban planning. As a result of the first step, 122 papers were selected. The second evaluation step involved a content analysis in which all 122 selected papers were analyzed, and as a result of the second step, 57 papers were selected. With regard to the data analysis, the main research question was broken down into four sub-questions that guided the content analysis of the papers. The table shows the sub-questions specified through a description of the interpretation keys. In relation to the general context, 49 papers refer to the municipal scale, 2 concern to the metropolitan level, 2 focus on an intermunicipal level between municipal and the regional scale, 3 refer to the regional scale, and 1 concern to the national scale. In relation to the national scale, for example, Bassett et al. Studied the thermal contribution of land cover change to population between 1975 and 2014. Britain. Moreover, with reference to the 49 cases that refer to the urban scale, 29 cases studied the entire municipal territory, while 20 focus on part of the territory. With reference to study analyzed parts of the city, 12 papers consider permeable areas such as urban parks, cemeteries, urban green system, forest areas, and urban gardens. In the remaining 8 cases, urban areas characterized by a mixed fabric comprising both sealed and permeable area are considered. For example, Murtinova et al. Studied the effect of the surface urban heat island in the city of Zvolen in Slovakia, analyzing the land surface temperature within 3 urban areas during the summer months in the period 2010-2021. With reference to the second sub-question's reasons, 37 papers focus the study on the phenomenon of urban heat islands. In the other 10 cases, the study of the urban heat island phenomenon is embedded within a broader study. For example, von Orson et al. Studied the best location of green infrastructure based on its ability to provide 3 benefits, that is, 3 ecosystem services, one of which is the reduction of the urban heat island effect. In reference to the paper that focus on the urban heat island phenomenon, 24 papers focus on the influence of permeable area on the temperature reduction, and thus on the urban heat island effect. Different types of permeable areas are studied, such as urban green areas, parks, forests, and urban green infrastructure. Moreover, 9 papers focus on the influence of land use and or land cover and the changes on temperature, and thus on reducing urban heat island effect. For example, Elliott et al. Proposed a study in which a simulation model of land cover changes was used to assess the effect of urban heat islands over time in the city of Lisbon. 5 papers study how landscape conformation influences temperature and thus the reduction of urban heat islands effect. 2 papers study the influence of water bodies on the urban heat island phenomenon. The remaining 6 papers focus on different factors. For example, Ramayana et al. Study how land surface temperature is influenced by 3 factors, that is, built up areas, vegetated areas, and the water bodies. In relation to the method and data sub-question, 37 papers use a remote sensing technique to assess land surface temperature. In 6 papers, air temperature are obtained through direct measurements. 2 cases assess both ground land surface temperature through remote sensing technique and air temperature through direct measurement. In the remaining 12 papers, the urban heat island phenomenon and the local climatic regulation are studied through other methods such as INVEST or I3 cool air model. In relation to the 37 paper using remote sensing technique, in 12 cases, the images analyzed refer to a single date. In relation to the 12 paper referring to a single date, in 5 cases, the image referred to daytime, in 1 case to nighttime, while in the remaining 6 cases, the time of the day to which the assessment refers is not made explicit. The remaining 24 papers that use remote sensing technique analyze images that refer to several and often very distant years, of which 9 have acquired images that refer to daylight hours, 2 to nocturnal hours, and 2 to both nocturnal and diurnal hours. With reference to the first questions, implication for spatial and urban planning, 32 papers suggest strategies and recommendations for policymakers and planners. In 13 cases, the authors decide to dedicate a special selection to them. The 32 papers suggesting strategies and recommendations can be grouped into 4 types: strategies at the municipal scales, guideline on individual intervention on the local scale, the methodological approach as a decision support, and the strategy and guideline that address both the municipal and the local scale. The result of the content analysis conducted on the 57 paper highlights several important aspects. First of all, the study of the urban heat island phenomenon in relation to ecosystem services has been a widely discussed topic in the literature for several years. The oldest analyzed paper dates back to 2011. Howard was the first scholar to describe the urban heat island phenomenon and its causes within his work, The Climate of London, where he described the study conducted from 1806 to 1830, during which he recorded the temperature every day for a year at 3 sites at South London and 1 within the city. The second aspect concerned the factor influencing urban heat island. According to the study conducted by Vogt, they can be traced to 6 aspects: geographic location, time, synoptic weather, city form, city function, and city size. Geographic location takes into account climate topography and the rural surround. Time considers time of the day and season. Synoptic weather considers wind and presence of clouds. City form concerns materials, geometry, and grid spaces. City function concerns the activities that take place in terms of energy use, water use, and pollution. And finally, city sites is connected with the shape of the city and the function that take place in it. However, according to Vogt, mitigation measures related to city form and city function are the only parameters on which a human being can operate it.
Only 2 minutes.
Yeah. The third aspect concerns the technique used. The vast majority of papers analyze land surface temperature through remote sensing techniques. The analysis of urban heat island required a reliable and consistent dataset. Prior to the use of remote sensing technique, the process to obtain such data was particularly laborious and costly, as it required the installation of meteorological stations. The process has been simplified by the use of remote sensing satellites, which have made it possible to study large urban areas due to frequent wall-to-wall coverage. Moreover, thermal information is provided both as a scene image and as individual products, making the process of deriving urban heat island intensity simpler. The fourth aspect concerns the implication for spatial and urban planning. At the international level, the 2030 Agenda for Sustainable Development and the 17 Sustainable Development Goals provide an important framework for the identification of climate change adaptation measures. In particular, Goal 11, Sustainable Cities and Communities, place resilient as a priority aspect in the future development of cities that adopt and implement climate change adaptation policies. Moreover, Goal 11, Climate action in target 13.2 call for integrated climate change measures into national policies, strategies, and planning. However, strategies defined at the international level have an indirect impact on adaptation at the local scale, as disagreements have been negotiated and signed by national governments. In fact, the adoption of this international framework does not lead to the implementation of concrete adaptation action by cities. At the national level, we have different examples. For example, Athens that have addressed its island in the climate change adaptation plan. Athens adopted the Athens Resilience Strategy for 2013-2017, and the latest climate action plan was published in 2022. In particular, one of the main objectives of the Athens strategy is to increase the area of green areas in order to decrease vulnerability of each island. To this end, Athens has quadrupled the budget for green areas, also thanks to the Greek state and the European Fund. In 2019, Athens obtained funding on the Natural Capital Financing Facility, a new financing instrument of the European Investment Bank that finances cities for blue and green infrastructure projects. In addition, 2021, the city of Athens signed the Urban Nature Declaration, which envisages the impermeabilizing between 30 and 40% of impermeable surfaces and ensuring that at least 70% of the population has access to green or blue spaces within a 15-minute radius. In conclusion, the study is a preliminary research that attempts to provide an overview of how its islands are studied in literature by using some key issues related to general context, rationale behind the study, materials and data, and implication for land use and planning. Future research development could concern the definition of climate-proof methodological approaches that integrate ecosystem services within spatial planning, with particular reference to the local scale. The principle of climate-proof planning at the local level can be a guiding factor in territorial governance processes, but above all, in the definition of a regulatory framework aimed at improving the quality of space and life in urban context. Thank you.
Thank you so much, Federica. And now we can move on to the next presentation by Stelios and Dimitris. Please, Stelios, the screen is yours. Stelios, your microphone is muted. Is it? Okay.
I'm starting the sharing screen, but it doesn't work. Can you do it for me, please?
The third button, so you have first the microphone, yes, and then the webcam, and the third one with an arrow is the one that allows you to share your screen.
It's okay now?
Yeah, it works. Please, let's have your slides now.
Perfect. So it's okay now?
Indeed it is. So I'll give you as a warning when it's 3 minutes or something left.
Okay. Okay. Thank you. Thank you. So I'm Stelios Kouzaleas. I'm assistant professor in the Department of Interior Architecture in International Hellenic University in Greece. So I'm gonna present you the work entitled Description of Pilot Digital Interactive Tool of Territorial Resources, Spatial Projection and Management. So before proceed to introduction, let's clarify some notions such as territorial resource. A territorial resource is a virtual structure directly connected to the space with the gradients of material, so tangible, or immaterial, so intangible dimension. The tangible is every permanent element of nature, of human construction, such as the landscape, the water, the monuments, the paths. The touchable notions is the heritage, the sustainability, the prosperity, the historical event, the social relationships, etc. The spatial connection is the interconnection of these ingredients associated with a spatial projection, with spatial simulation, allowing actors, decision makers, staying local policy citizens to be involved in the participatory process of a territorial resource construction. And a spatial projection is the simulation, the visualization in space that visualize the connection of these elements, material, of the territorial resource with the active participation of local actors and the collective local memory. So what is this work about? The aim is the theoretical, for instance, the theoretical description of a digital tool of territorial resources representation and management. There are many objectives. The main objectives are the definition of a spatial simulation digital tool with territorial resource gradients management and participatory actions, and the formation of a new cooperation and coordination forms, new governance, digital governance. Not only digital, of course. Methods, there are theoretical and technical implementation approach of the territorial resource digital tool, the spatial interaction between the ingredients and the stakeholders' participation. And the result is the theoretical description, implementation and procedure, and of course, the scientific social impact of the proposed digital tool. Some words about to introduce this work. Today, regions seek competitiveness through distinctiveness, and consumers search quality and authenticity. A significant change in the relationship of the produced good or service with the place of origin. Today, it's a real fact. The territorial resource results from a series of material and immaterial elements anchored in space, connected to the space. The effort to highlight the uniqueness of the resource and the final products encounters difficulties project the connection of the material with material elements. For example, if anchoring space and place is easy to demonstrate, for example, it's easy to demonstrate, to visualize a building, surface, cultivation, etc. The integration of living heritage and local culture is more difficult, as it refers to knowledge and know-how that is often informal. So there is a need to support the identification process with special claim guarantee tools. For example, the participatory guarantee system, the PGS, using new visualization technologies. So this system, participatory guarantee system, aimed and uniform consumers, understanding the ingredients in their connection with the resource, but also used by local actors in a learning process, such as the management of territorial resource, the control and strengthening of guarantee instruments. Active participation in a PGS system creates trust, transparency, reciprocity between producers, products, and consumers, while facilitating consumer knowledge. A territorial resource management should, inter alia, be a part of such a system, participatory guarantee system, represent the area that the resources and the actors refer to, integrate local actors and support them, contribute to the interconnection of these elements, and facilitate the distribution of roles within coordination forms, and draw an action plan for the promotion and utilization of these resources. A few words about the project framework. Terra Thessalia cluster is actually a participatory guarantee system project. Was created in 2016 in the framework of Ultimate European Program, aiming to strengthen the production and distribution of innovative dairy products in the Mediterranean, and proposing a PGS managed by territorial administration via an organization of local industries. So creation and development of all guarantee certification traceability processes with a pilot interactive visualization tool of participatory guarantee system tool. This tool visualizes spatially all the PGS mechanisms from dairy production process to the traceability, the local product attachment, with the unique territory that we call territorialization, until the consumer's participation and the final specific guarantee natural product, certification of process, animal feed, certification of animal milk quality, even remote monitoring with GPS information of animal path location. For example, as you see and on the photo on your right, we made we anchor a GPS on the neck of many animals in order to remotely monitor these animals by drones, and so we have the paths, the animal path, the location, and even we know that when they stop, for example, we remark that there is a quality of feed, etc. The proposed digital tool aims to enhance the spatial projection of these elements, identify, register, and correlate all the ingredients, and adapt the territorial resource simulation tool as an integral part of a feature holistic tool, territorial resource management, but construction even tool. So some words about, let's give it an example of Terra Thessalia cluster. This is an agri-food chain with main links such as the geoproduction or the artisanship unit that conclude some components like livestock, grazing, feedstuff, space, milk, collection product, and each component, for example, livestock, consists of sub-components with such as the herd, the animal breed, and of course, in the some components they are associated with intangible ingredients. So the tool operation criteria is the anchorage in space, incorporation of these units, incorporation of these components, correlations, etc. So some examples about the tangible ingredients and the intangible ingredients. The tangible ingredients is what we have of the nature, the landscape, the water, the flora, the microclimate, and the human is the building, the paths, the bridges, the monuments, but also there are immaterial ingredients, such as the heritage, the sustainability, the prosperity, the historical event, the social relationships, and also some complements, such as the principle and the values, the legacy, the proximity, the quality, the solidarity, even the tradition. We have on the right photo the 3 generations in the same family of breeders, for example.
Sorry, 3 minutes.
3 minutes only. Oh. So tool description. I'm going to proceed. So the theoretical approach. This system is not a decision support system, as it activates the participation of local actors to create a database. Technical approach. Let's talk about the technical approach. So it should be a digital online combinatorial platform, for example, an open source technology with SQL server, Java, HTML application, allowing 3 main interconnected features management. So the first one is the multimedia visualization. The second one is the dynamic online database. The third one, online consumers participatory deliberation form. So about the web visualization environment, it's all the multimedia elements such as the 360 virtual tool plugins, video, multimedia interaction, HTML5, JavaScript, GPS, etc. The online dynamic database, which is at the same time simulation and descriptive form data. With form builder data, query builder, remote database access, or synchronization, etc. An online participation, consumer participation deliberation forum, an advanced forum with creating of users, forum access sets, social networks, etc. So in the end, to conclude with some state-of-the-art features, here we have a bottom-up participation of local actors in a participatory procedure of territorial development, combining territorial resource visual spatial information, multi-pattern procedures, territorial resource gradients connected to an online descriptive and simulated database. The second one is the territorial resource gradients correlations with the spatial projection to database, enabling the development actions, integration of new production systems, or even creation of new specific products. And the third one is feature territorial resource construction tool that this we want to arrive to aim to construct to build a construction, a territorial construction, not only management tool, creating convenient conditions for local rural communities for the meeting of traditional knowledge on one hand, and on the other hand with new scientific knowledge, and contributing to enhance supply of ecosystem services and sustainable management of territorial resources. Thank you very much for your attention.
Thank you so much, Stelios, and also for keeping to the time. Now, still there's 15 minutes or so left, and then we can collect the questions to everybody in the room. So Bilge, Federica, Silvia, Corrado, and so on, please, you can switch on your cameras. And let's see if anybody has any questions. Okay, of course, I will not ask any questions to myself or to Corrado. So let me start with a question to Silvia, whose studies I always like so much. And I was really intrigued by the maps you had. And I was wondering, especially as far as air purification is concerned, whether you're kind of reflecting on environmental justice issues. So who's living in the better areas as far as pollution is concerned, and how we can address, if you are taking this into account, this issue.
Yes, thank you, Sabrina, for your question. I think that mapping ecosystem services can also help to make some reasoning about what is the condition of such areas inside cities, and also to understand what are the disparity between some areas that maybe are more best planned and have a huge amount of natural components that can increase the quality of inhabitants in this specific area, and other that are more industrial, more impermeable, with less opportunity to use a natural area for recreation, also for a better quality of life in terms of also well-being and mental health. Surely our approach is also to combine this more social aspect inside the strategies that we would like to support new urban planning process. So try to combine the sustainability not also in the environmental perspective, but also combining the social opportunities that also ecosystem services can provide, and also trying to have a balance between a different combination of sustainability aspects. So it's very interesting also what you highlighted. So it's something that we also want to integrate inside our urban metabolism analysis.
Thank you so much. And next to Bilge, I was wondering whether you have thought intensively about the limitations of the STMAP approach that you used, although with some variation to take into account the dismissed railway networks, so the possibility of it's being converted into some kind of greenway, and whether once you have identified the limitation of the model that you have used, whether you see any room for improvement, or whether you think that perhaps you might look for kind of other kind of models which might better fit your purpose.
Yes, one of the limitations I had was including somehow railways, different types of routes, a third layer into the equation. So instead of superposing it, I could somehow, I wanted to include it in the model, but there was no room for that. So I had to add it as an additional step. So that could be an improvement for the model. So it could be used in other typologies of green infrastructure.
That was very short, and well, we can discuss that further outside the conference, I suppose. So for Federica, so apparently there's lots of studies which have already analyzed the urban heath islands and ecosystem services. So how to address this phenomena in urban studies. Still, it seems to me that the research is not there yet. So what kind of research gap, rather than policy implications, which you already showed, which is there, which is still lacking in the literature, and can it be tackled, or it's still quite far away?
Okay, thank you for the question, Sabrina. And this study was a preliminary study in order to understand also what you are talking about. So, what are the gaps within the literature in order to integrate the topic of the urban heat island effect also within the planning processes. In general, the main one of the main gaps is that in the study, only a few papers suggest policy, recommendation, and strategy on how to integrate this phenomenon, and so the mitigation measure within the planning instrument. So I think that it is a fundamental gap within the study that we are conducting. And the majority of paper just assess and map this typology of phenomenon, but without a solution, or maybe without a recommendation, suggestion, it's not possible to deal with this kind of problem. Of course, the knowledge about the problem and what are the more critical areas is fundamental, but is not sufficient to deal with the urban heat island effect. I don't know if I answer your question.
Yeah, to some extent, yeah. And for Stelios, well, that left me with a question. I mean, everything is related to everything, and so how to manage the space, how to involve citizens, how we manage natural resources. But then, what is the exact role of ecosystem services in your studies? I mean, you touched upon a little bit in the final part of the presentation. Can you please expand a little bit more? Oh, you're muted. You're muted. Can you switch on your mic, please?
Sorry. Thank you.
Thank you.
your question. Actually, I should say that every element of an ecosystem can be a territorial resource element. From nature, the water, from the human activity, monuments, bridges, paths, etc. But also, this is which is very interesting, is that in all these kind of territorial resources, so material territorial resources, we can connect these ingredients, these elements, with immaterial ingredients, which is very important to an ecosystem, to the space, such as the know-how, the tradition, the solidarity. So the first one is easy to visualize a building, visualize the water, but it's very difficult to visualize all these immaterial elements, which is perhaps more important than the material elements, such as the solidarity, for example, the know-how, the tradition. So we are trying to do that, so to found the interconnections between the material and the material elements, and try to connect them, to project them, to visualize them spatially, because they belong to a space. And the space is very, very important. So this is the relation with an ecosystem. The fact that every element of an ecosystem can be an element of territorial resource. So we try to manage these elements, not only to manage the future goal is to create a system, a tool of territorial resource construction, and make in it all these interconnections between the material and the material elements.
Thank you for clarifying this. Does anybody in the room?
Sabrina, yeah. I have a question for you and Professor Toppi about your presentation. And the first question is, do you plan to include other ecosystem services or other typologies of ecosystem services in future development of your research? And the second question is, how do you think that this analysis can be integrated into planning processes at the urban scale?
Okay. Corrado, how do you want to deal with that?
Yes, with reference to the first question, I would say that, as Federica knows very well, we are going to develop a research concerning the spatial taxonomies of a set of ecosystem services at the regional, I would say at the rural regional scale, which includes the capture carbon capture and storage, and seems to me that it doesn't include runoff control, as we did in the case of the urban environment of the municipality of Cagliari in our presentation. But then it includes recreational, I would say, cultural ecosystem services and agricultural production, and so on and so forth. So for sure, the answer to the first question is the way of considering spatial planning as an holistic process, which should include several kinds of ecosystem services is a perspective that cannot be neglected anymore for the future, we would say. And I would say that in terms of urban planning processes and policies, programs and projects, this needs maybe an increase in the availability of data which need a suitable and adequate level of detail. So I would say that for sure the ecosystem service-based approach to spatial planning has a lot of room. There is a lot of room for future improvement, and one way is for sure that you have to enlarge the set of ecosystem services that you have to consider in order to make as holistic as possible the ecosystem service-based approach to urban and regional planning. And the spatial implication goes together with the detail, the precision and the quality of the data available at the different levels of spatial planning. In terms of the urban planning implications that we have presented, of course, in the case of the municipality of Cagliari, and with reference to runoff control, carbon capture and storage, and heat mitigation, those implications are strictly linked to the effectiveness and utility of those implications are strictly based on the quality of the data, and as Sabrina put in evidence in the presentation, not all the data are of excellent quality. So that is another a very important profile that should be taken into account. And can I raise a couple of questions? Me too, just very quickly.
Sure, go ahead.
One question to Silvia. In the case of the Turin municipality, you presented with reference to the analysis of the urban metabolism, several spatial taxonomies, for example, the runoff control taxonomy, or another taxonomy which was related to the tree canopy, it seems to me, but I don't remember if it was related directly to carbon capture and storage or to heat mitigation. But anyway, my question is the following: are there the data that those taxonomies are based upon? Are primary data, or are estimates? Are based on estimates? For example, the runoff control. You said that 56 of the total rainfalls represents the runoff. Is this something which is estimated or directly detected? And the same for the state of the canopy in different parts of the city. Is the carbon? It seems to me the carbon capture and storage or the heat mitigation estimated or directly measured?
Yes, these are assessments that we did using Invest. So we collect data from the municipality and we run the model. So it's an estimation. We don't do directly a site-specific investigation to understand if our results correspond to the strict reality. We think that we have enough information and data to think that our estimation is quite close to the reality. Also considering the recent problem that the city has with rainfall that cause urban flooding. So and also the location that we estimate. So our location, when the runoff is concentrated, correspond to some of the recent events in terms of stormwater, that the rainfall is not absorbed by soils because it's totally impermeable. So, and also the data, for example, collected from the tree cataster, we use i3 that, okay, we create all the database that need to be customized corresponding of our climate condition, because it's a model developed in USA. So some issues is different from our climate condition from the USA condition. So we found some correlation and something that we need to change to have a better results also from this perspective. Are totally an estimation, but we have also our some data that the municipality give us to create an assessment that could be quite close to the reality, but still an estimation, not something that we goes directly in the soil to understand.
No. I didn't mean that you go to, but maybe you get data directly from someone who detect data with direct observations.
We have something similar for the emission, so the pollution emission, because they know what are the sources of this emission. And also the cities for participate to the project of 100 cities that are towards climate neutrality need to fill in a schedule quite complete of information considering the amount of emission of the cities. And this is quite, it's a data more precise that our assessment. So we want to combine all of this information to understand if the emission could be reduced considering the quality of the ecosystem services. And also we see that no, so the emission are, the amount of emission are completely, it's a number quite higher, and the ecosystem services need to be increased to mitigate in reality this issue.
Sorry, guys. I got a message from Hanoi, and they are going to close the Jitsi room right now. So I'm sorry, there's no room for further questions. And thank you, everybody, for taking part in this session. And we look forward to seeing you again in other opportunities.
Bye-bye.
Thank you.
Bye. Thank you very much.
Bye.
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 We are closed now. Thank you very much.